Okay, today we are converting between forms. You did this in IM2. It is simplifying radicals. That's what we are focusing on today. I know in IM2 you focused a lot on squares, but we're doing cubes, fourths, and sometimes fifths. Tomorrow when I'm gone,
You'll be gone?
Yes, I'm on campus, but I'm not here.
Why?
Because I have a meeting today. So tomorrow you're going to practice simplifying radicals and using your exponent rule. So pretty much what we've been doing for the past week and a half. And Friday is your first quiz of the semester. Followed by a 3-day weekend. So there you go, yeah. Okay, we're going to get started. The first thing I want you to write is a top portion where it says simplifying radicals. That is the topic. That is what we are doing today. And here is what we do. Okay, my first one is square roots. Square roots. I need to find groups of how much? Square root says find groups of 2. Now, the number that needs to be in our group depends on what our index is. Okay, our index is right here. Is there a number written here for square roots? Is there a number right there? Did I write a number in? No, there's an unwritten 2 in this index. Okay, so our square roots are looking for groups of 2. What about our cube roots? How many groups? Our cube root is groups of
3.
Our cube roots are groups of
3.
Okay, April knows. What about the rest of you? Cube roots are groups of 3. Of cube, yes, of 3. And do you see how my index right here is 3? The index is that little number inside the radical symbol. That's called an index. Finally, for our last one, okay, these are our fourth roots, and these are groups of how much? Fourth roots are groups of 4, okay? So if I say square root, you're finding a group of how many? 2. A cube root is a group of... Okay, I see a lot of yawning. Let's wake up.
3.
Let's start again. Square root is groups of... Square root is groups of 2. Good. Cube root is groups of 3. And fourth root is groups of 4. Okay. So number 1, the square root of 24 is something that you definitely did in IM2. I know you did it. Whether or not you remember it, that's a different story, but you have done it. So we are going to break this down. How do we break it up? Yes, Jessica, what's that called?
Tree.
Yes, a factor tree. Perfect. Okay, so we're going to do a factor tree. So what goes into 24? What are factors of 24?
12 and 2.
I like to use 12 and 2. Okay, what are factors of 12? 6 and 2. What are factors of 6? 3 and 2. Can I break that down any further? No. I do have to circle some things, yes. So what am I looking for? What's my index? What's that number that's unwritten? Groups of 2. So I'm going to circle my groups of 2. So I have one group of 2. Can I circle anything else? No, so I'd like to box it. Okay, if there are no pairs, I'm going to box it. How come I didn't put a box around the 6 right here? Yeah, because that can still be simplified because I can split it up. Yes, because I found the factors of 2 and 3. Okay, so this 2 and the 3 stay inside my my radical symbol. Yes, you all did this. We will multiply it. Okay, now see how I have one group of 2 here? That just comes outside as a singular group of 2. So my final answer is 2 radical 6. Okay. Oh, you'll get a challenge. We have quite a few more examples to go through today. Okay, how are we on number 1? Is that a good refresher from last year? Yeah, what about number 2? What's different about number 2? There's a cube root, so that means I need groups of 3. So we're going to do the same thing. I'm going to break it up the same way. I get the same factors. But instead of groups of 2, I need a group of 3. So I have 1, 2, 3 2s. And what do I do with this lone 3? I put it in a box and it goes inside the radical. Yep. So here's my radical. And actually, it's not just a radical, it's a cube root. My 3 goes inside. And this group of 2s comes out. So that means my answer is 2 cube root of 3. We're going to keep going. Next example. What is different about number 3 compared to 1 and 2? Yeah, the number outside it has that 3. So let's still do the same thing. Let's start the same way. So I'm going to break up 24 the same way I have been. And I'm looking for groups of how many?
3.
Okay, I'm looking for groups of 3. So I have 3 2s as a group. And then what do I do with this? I put it in my radical. So when I box it, it goes inside my radical. This group of 2s comes out here. And then, am I done?
No.
Yes, correct. I'm not done because I have this 3 right here. And I multiply it. So what is 3 times 2? 6. Then the rest of it stays. Cube root of 3. Here is my final answer. Let's look at number 4. What's even more different about number 4? It has a negative. And I know how much you all love negatives. I know you don't. So here's what we're going to do. Yes, Diego. We don't, actually. That was a good thought, but no, it's not like a reciprocal with my negative exponents. Good idea, though. Instead, yes, we will. Here's how. So I can write this as the cube root of negative 1 times 72. Why did I write that? I'm trying to, take care of the negative and get it out of the way for a little bit. Okay? So I have the cube root of this negative 1 times 72, which can also be written as the cube root of negative 1 times the cube root of 72. So anything that's inside, I can break it up and give it its own radical symbol. Okay? Now, the cube root of negative 1, that is the square root. That's a good idea. Okay, so when I take the radical of a negative, it is sometimes imaginary. Okay? In this case, I have 3 as my index. Is 3 an odd or an even number? When it's an odd number, it's good. When it's an even number, it's not. So that was a good idea. So right now I'm going to write something. Don't copy this down yet, but please pay attention. So when I have the square root of negative 1, what did you guys normally get for that? Can you take the square root of a negative number? No. What did you guys call it? It's an imaginary number. Not good. Yes, right? But I have on this question the cube root of negative 1, which I can take, because that just means negative 1 times negative 1 times negative 1. So that's okay. The square root of negative 1 is no good. The cube root of negative 1 is okay. So when I have an odd index, I just take out a negative 1. And when it's an even index, that's an imaginary number, okay? So the cube root of negative 1 is just negative 1. We're going to leave that for now. Does that make sense? What happens what? Leave it for now. We will use it in a minute, okay? So the cube root of negative 1 is negative 1. Yes? Okay. Only the odd, yes. Okay, so look back up in the middle. So you see how I have the square root of negative 1? That is an imaginary number. That's when we get I. Remember learning about that last year? Okay. Now, what I had is the cube root of negative 1. The difference between these is that this root is 2 and that root is 3. When you have an even radical like this, 2, 4, 6, 8, 10, so on, I will get an imaginary number when a negative is inside. If the index, which is a small number, is odd, so 3, 5, 7, 9, 11, and so on, that just means that my root will be a negative number. Okay? Because negative 1 is, I can say negative 1 is negative 1 times negative 1 times negative 1. So this gives me a positive 1 times another negative 1 is negative 1, and that's how I get it, okay? So the cube root of negative 1 is just always going to be negative 1. Keep that in your mind because typically it will be a cube root. Does that make more sense? Okay. Is that cleared up a little bit for those of you who are a little bit more confused? Okay. We're going to take care of the 72 now, the same way we did before. So how do I break up 72? What are its factors? Let's do a factor tree. Okay, 8 and 9. What goes into 8? 2 and 4. Good. And what else? 2 and 2. And then 9 breaks up into 3 and 3. Okay, so I need groups of how much for this problem? I need groups of 3. So I have 1, 2, 3 2s. And 2 3s. So what do I do with the 3s? Yeah, leave them inside. I'm going to box them and leave them inside. So I have the cube root of, let's take my boxed 3s inside. And then my group of 2s comes out here. Do you follow along so far? Now is when I can take care of my negative 1. Whoops, and write it out here. So that means my final answer is negative 2 times the cube root of 9. Okay, does that make more sense? Okay, now that I showed you a different thing, or the fourth example, I want you to reevaluate the first 4. Can you show me out of 5? How do you feel about the first 4 examples? Okay, number 5. What is different about number 5? I have variables and they have exponents. Okay, remember I told you, yes, it gets harder, but it's just because I'm adding more and more things each time. So let's separate this again. We're going to follow the same steps that we have been. Same exact way. Yeah, it helps me remember that I can separate them and do it all in separate parts. Okay, so we're going to take care of these all on their own, and then we can combine our answer at the end. It's the same way when we were doing our quotient rule, separating it by like terms. So for 48, we're going to break it down the same way we have been. What are factors of 48? 12 and... Okay, we can do 12 and 4. I'm going to do, 4 and 12 like this. What does 4 break up into? 2 and 2. And what does 12 break up into? 2 and 6. And what else? 2 and 3. Okay, now, what's the index? How many groups do I need? I need groups of 2. Good. So I have one group of 2, another group of 2, and what else do I have? A single 3. So I like to box it and make sure to put it inside. So I have 3 inside and a 2 and a 2 outside. Does that make sense so far? Okay. Yes, it will be 4 when we finish simplifying it. Okay, now I'm going to take care of my a cubed. And we're going to do this the same way you guys discovered your exponent rules last week. So I'm going to expand it. Do I like expanding it all the time? No, but for explaining it the first time, yes. Because I'm going to tell you on the next slide, I have c to the 23rd power. Do I want to write 23 c's? Yes, you want to write 23 c's? Be my guest, but I'm not doing that. So we will find a simpler way on the next slide, okay? But for now, this way works. I need groups of how many again? 2. So I have a group of 2, and then what? Box the other a. Good. So I have 1a inside. And then this paired tells me a outside. And then finally I have b to the 7th. So how many b's am I going to write? 7 of them. Okay, Okay, so even writing 7 B's is a lot of work. But we'll do it for now. I need groups of 2. So how many groups of 2 do I have? I have 3. Good. 1, 2. Let's try this again. 1, 2, 3. And what else do I have? I have a single B, so I'm going to box it. So I have the square root of that single B. And then since I have 3, I have B cubed outside. Is that okay so far? Okay, good. Now I can finish my problem. So I'm going to take this simplified answer, this simplified answer, and this simplified answer, and I'm going to combine all of the like terms, or combine all the outside and the inside terms. So I have 2 times A times B cubed. Those were all of my outer terms, times the square root of 3 times A times B. And that's going to give me 4AB cubed times the square root of 3AB. And that's my final answer. Okay, so I saw a lot of good work. I saw that 32 breaks down to be, so this is 2 and 16, 2 and, 8, 2 and 4. Keep working. You don't have to look up here if you're not ready yet. Here, I'll do this quietly and then I'll walk through my work at the end. Actually, let's do this. I have 2. Okay, so do you all get this part? And then I did see, and I'm really happy that you all took this 3x and multiplied it here as well. So 3 times 2 is 12. Sorry. I should have written 2 2s. That was my fault. Yes, I made a mistake. This was 2 and 2. Yes, I'm sorry. I was thinking too fast. Remember I told you sometimes I do that? So I should have 12x squared. 12x cubed. Oh my goodness. Let's erase this line. Start again. Okay. 3 times 2 times 2 is 12, yes? Yes. X times x squared is x cubed, yes? Okay. And then the square root of 2y? Is that what we all got? Okay, good. Okay, we're going to do our last example. This is the spiciest one yet. You're going to love it. So on the next slide, we're going to skip 7, and we're doing number 8. Okay, number 8. Let's look at number 8. I'm going to rewrite it so I have some more room. This is our last example. So I said it's the spiciest one of them all. We like spicy food in here. Okay, it's a lot easier than it looks, okay? Yes, it is. We're going to skip number 7, yeah. Because if you can do number 8, then you can do number 7. Okay, number 8. I can rewrite this as the 4th root of 625 times the 4th root of c to the 23rd power times the 4th root of d to the 11th. Okay. So if we start with the 4th root of 625, I need to find the factors of 625 that multiply by themselves 4 times, but I don't know that. So instead I'm going to look at my special powers table. So you all have a special powers table. So go to the 4th column and find 625. Yes, 625 is 5 to the 4th power. And that's what I want. Okay, does this make sense? Okay, so that means that I have 5 times 5 times 5 times 5, which is my group of 5s. Does that make sense? This is my group of 4 5s. But I don't want to write that down every single time. So since I have one group right here, that means I'm taking out just a 5. I have no radical left. So that's the first part of my answer. Just listen to me. I'm going to box it for now. Just hold on to it. Okay? The fourth root of 625 is 5 because 5 times 5 times 5 times 5 is 625. Okay? Let me show you the next one. I think it'll make more sense when we see that. Do I want to write C to 23 times? Do I want to write it? No. Can I? Yeah, but there has to be an easier way. How many groups or how many are in each of my groups? I'm looking for groups of 4. Okay, so how many times does 4 go into 23? 5 times. So let's write it 5 times instead. Let's see. Do I have 1, 2, 3, 4, 5? Okay. So that means I have C to the 20th, right? Okay, so here is my 1, 2, 3, 4, 5. So that comes to the outside. I don't write C to the 4th outside. I write C to the... How many groups is that? No, 20 is the number inside. I write C to the 5th power. Okay, the reason for that is because I have 1, 2, 3, 4, 5 groups. And that's where the 5 is coming from. Does that make more sense? Because I can write C times 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 C all the way up to 20. Okay? But how many did I actually need? I need 23. So 23 minus 20 is how much? 3. So that means inside are my remaining 3. Do you understand that? Okay. So I'm going to box that part so we remember to use it later. And then I have to do it one more time. For what? For my D. So how many D's do I have? 11. And I need groups of 4. So how many times does 4 go into 11? 2 times. So I have D to the 4th times D to the 4th is D to the 8th. So here is my first group and my second group. Why can't I go in 5 times? What's 4 times 5? Okay, so that means I have a D squared that comes out because I have 2 groups. 1 group, 2 groups. And then how many did I need in total? 11 minus 8 is 3. So that means that I have a cube left inside. So this is the last part of my final answer. So I can smush all those things up together, outside, outside, and inside, inside. So I have 5, C to the 5th, D squared. Oh man, I made 2 mistakes. Just making all these kinds of mistakes. What is the index of this radical? 4. Did I write that? No. Oh my goodness, I know. I need to go to sleep instead of playing games when it's past my bedtime tonight. Oh. Okay, so I have the 4th root. I was playing Candy Crush. Of what's left inside? What's left inside? C cubed, D cubed. Okay, and this is my final answer.